This time we'll discuss the conservative model, and using the conservative model we'll show that the maximum value of the normal stress developed by conservative model will be higher value as compared to what we obtained using the mathematical model of a normal stress as well as the shear stress. Now this time we are working with the conservative model. In the case of conservative model, you have to use the value of theta equal to 45. And I will show here, if I use the value of theta equal to 45 and I neglect the effect of normal force, only the effect of shear force is considered. So in our figure we'll only show the Fs value, that is the shear force. So we'll consider this triangle ABC here to develop the relation between T and H when we are using the conservative model, that is theta equal to 45. So this point is same as equal to A. We have A to C is same as equal to the H, that is the leg size. A to B is same as equal to the throat thickness equal to T. This angle already we know is 45 and this angle we assume as 45. So this angle must be 90. So this one is a right angle triangle, and if I use the value of cos 45, then this one is adjacent and H is a hypotenuse. So we have cos of 45 is same as equal to the adjacent value is equal to T divided by hypotenuse equal to H. In that case I will get the throat thickness equal to H into cos 45 is 0.707 multiplied by H. So we have the throat area, which is represented by A is equal to T multiplied by length of weld. So we have throat area is same as equal to 0.707 multiplied by H multiplied by L. So in the conservative model we are taking the value of theta is equal to 45, will only consider shear force, and the normal force value will make equal to 0. So what exactly the conservative model means, that the normal value of the force is decreased, therefore the normal stress will vanish. At the same time we are going to increase the value of the shear stress at the throat. We have shear stress will be same as equal to tau. We have shear stress equal to force, which one is the shear force divided by the area A. So only force acting is Fs, so shear stress will develop, and we have tau is equal to Fs divided by the area at the throat is 0.707 multiplied by H multiplied by L, 0.707 multiplied by H into L. If I take a reciprocal of 0.707, I will get this value is equal to 1.414 times F divided by HL, where H is the leg size and L is the length of weld. And the shear force is replaced by F, Fs equal to F. Since here only one stress is acting, the stress element is shown here, which one is purely the value of tau xy is same as equal to tau. So this one is a case of pure shear. Hence we have tau max is same as equal to tau because of pure shear is given as 1.414 times F divided by H into L. And this value we assume as a conservative model will occur at theta equal to 45. But for any angle theta, which one is a mathematical model, we have tau is given as this equation, and if we differentiate with respect to theta equated to 0, we come to know that at theta equal to 67.5, we have tau max equal to 1.207 F divided by HL, which is equation number 2. So let's say this one is equation number 3. What we have done previously to find the value of maximum shear, we have differentiated. In that case we get theta equal to 67.5 and we obtain the value of tau max, which one is a mathematical model, gives you tau max equal to 1.207 F by HL. In both these equation 2 and 3, F divided by HL is same value. Coefficient here in this case is 1.207, and in the conservative model we have coefficient is 1.414 F. Naturally, this value of tau max, which is given as 1.414 F by HL, is a higher value as compared to the tau max which is obtained by using the mathematical model. So if we compare 2 and 3, we observe that tau max given by conservative model is higher as compared to tau max by the mathematical model. So you have to always prefer the conservative model as compared to mathematical model. because if the material will fail by a conservative model, then all is almost failed by all models. At the same time, we can calculate here the bond stress sigma using the pure shear. So already we have done the theory of failure, so we know how to calculate the value of the largest one misses stress if we know the value of shear stress. So we have maximum value of the normal stress sigma prime max is same as equal to root 3 multiplied by tau. This tau is same as tau max value, which is equal to 1.414 F divided by HL. So we have root 3 into 1.414 multiplied by F divided by HL. So in this case, we have sigma prime max, that is the largest one misses stress, is root 3 multiplied by 1.414 will come as 2.45 times F divided by H into L. And if we calculate here using a mathematical model at any angle theta, the largest one misses stress come out to be sigma prime max is equal to 2.16 times F divided by HL at theta equal to 62.5. So let's say this is the equation of 10 by a conservative model, which gives the value of sigma prime max, that is the largest one misses stress. And equation number 1 we have derived when we have theta is equal to 62.5. Again, you compare the coefficient here. This value is 2.45 and here this coefficient is 2.16. So conservative model always give you the maximum value of the tau max as well as the maximum value of the largest one misses stress. So again, from equation number 4 and 1, we observed that the largest value of the one miss stress, which is equal to 2.45 F by H into L, is the largest value when we derived the mathematical model. So this equation we are using as a mathematical model, and this equation we obtained by conservative model. So in all, we can find here that a conservative model always give you better idea of the stress as compared to the mathematical model. So when we are using the conservative model, that time the value of the normal force we made equal to 0, and only the effect of shear force we have considered. When the effect of shear force is considered, the value of tau max we obtained as 1.414 Fh by L. In mathematical model, we have considered both the effect of shear as well as the value of normal force Fn. In that case, we obtain the value of tau max, which is given as 1.207 F. So this one is a lower value. And normal stress, which is obtained in the mathematical model, is sigma max is given as 2.16 F divided by HL. Whereas in a conservative model, we obtain the value of sigma prime max, which one is the largest one misses stresses, is equal to 2.45 F divided by HL. So conservative model gives a better design stress as compared to mathematical model. Hence, in practice, we always select the conservative model as compared to the mathematical model. And this idea is best idea, that is, neglect the normal force effect and consider shear force only. So whether it's a transverse loading or a parallel loading, as we have seen previously, only the effect of shear force you have to consider, that is the effect of shear stress you have to consider. So whenever we are designing the fillet weld, always use the conservative model. That is just we have explained here. That is only the shear stress acting at the throat you have to consider, and there is no normal stress you have to consider in designing the fillet weld. So this formula is useful for us, which one is tau max is given as 1.414 F divided by H into L, and the failure will occur at theta is equal to 45. Now in the analysis of the welded joint, it is decided now we're going to use the conservative model, that is the value of Fn will be equal to 0, only the value of the shear force will consider, and we have tau max is equal to 1.414 F by H into L. Now this value of tau max we want to calculate here what is the permissible value of the shear stress. That is, we want to analyze here the strength of the welded joint. So let's discuss the idea about the strength of the welded joint. To find the strength of the welded joint, we'll consider here the two plate and has a fillet weld. Now we know here at this point here somewhere near the parent material at the weld zone, So this one is basically due to the parent material and the filler material. Similar to this, we have one more zone is formed which is near the second parent material and the filler material. And if you consider the middle section here, this one is also consists of the filler material and the parent material. So you want to just check here the safety of the weld metal. For this one, we will going to check here that is the filler material is sufficient to hold the welded joint. So in the analysis of welded joint, we want to check here that the filler material is safe or not. So we'll select that filler material whose value of shear stress will be higher value as compared to the tau max which we have developed. So we know that the tau max here is, according to the conservative model, is given as 1.414 multiplied by force F divided by H into L. So you have to select that filler material whose shear stress will be more than the given value. Then the joint is safe. So value of the tau max must be less than equal to the tau of filler material. Similarly, the value of tau max should be less than equal to the value of tau for parent material. So here I collected some data for the electrode. Electrode number has 4 digits are used. First 2 digits represent here the tensile strength, and the rest 2 digits will give you the position where you have to use. These numbers are given as 60, 70, 80, 90 by AWS, which one is American Welding Society. Two value I have collected, one is the tensile strength and second is the yield strength. Inside the bracket we have megapascal value, and then we have the kilo pound per square inch value for both tensile as well as yield strength. So first 2 digits in the electrode number gives you the value of tensile strength in kilo pound per square inch. So this number is 70. It means that we have tensile strength is equal to 70. This number is 80. It means that we have tensile strength is 80 kilo pound per square inch. And the third column gives you the value of the yield strength. So this column representing the ultimate strength, that is value of SUT, and this column represents the value of SYT, that is the yield strength in tension. SUT value is always higher value as compared to SYT. 62 is higher as compared to 50, 70 is higher as compared to 57. So it is your job to select the right electrode or the right filler material. Then only the welded joint is safe. So you have to always select the filler material or the electrode, and we have to match the tensile strength or the yield strength of the metals, that is the parent metals. So welded joint is subjected to different type of loading. Some idea I give here. Type of loading is maybe tension, bearing, bending or shear. Type of the weld can be butt weld or can be butt or fillet weld. We have an idea about the SYT and SUT. If the type of loading is tension and you are using the butt, in that case the permissibility of the stress will be 0.6 times of SYT. If it is the type of loading is a bearing, then the type of the weld is butt. The permissive value is 0.9 of SYT. In the case of bending for type of weld equal to butt, the permissive value is 0.6 to 0.66 of SYT. Now we are interested in the shear. Whether we have butt type of weld or fillet type of weld, the permissive value of the shear is 0.3 times of SUT, not SYT. So SUT value is this column. In addition to that, you have to check that the shear stress of the base metal must be less than equal to 0.4 of SYT, that is 0.4 of yield strength. So as far as the shear is considered and we have either butt or fillet, in that case the permissible stress will be 0.3 of SUT or 0.4 of SYT. So we have the shear value. So we have SSY, that is the shear strength in yield, is same as the tau allowable. We have to select this value as a minimum value between the value of 0.3 SUT or 0.4 SYT. So in this case, you have to select the minimum value out of 0.3 times ultimate tensile strength or 0.4 times yield strength in tension. But since here we have 3 zones, zones form. One is a fusion zone form here, which one is a parent material 1 and the filler material. This one is also a fusion zone form with a base parent material equal to 2 and the filler material, and this one is also a parent material 1 and 2 both plus filler material. In that case, you have to select the minimum value of SUT out of filler material or the parent material 1 and the parent material 2. Similarly, SYT you have to select as a minimum value of the electrode or the filler material or parent material 1 and parent material 2. So to calculate the value of minimum value of ultimate stress, you have to select the minimum value of the electrode or the filler material or the parent material 1 or the parent material 2. Now same thing you have to do for the yield strength in tension. You have to select the minimum value of the yield strength of electrode or the parent material or the parent material 2. How to select the value of SUT for electrode, that discussion we have done here. So this data is available in the data book. You can check for electrode number, tensile strength and the value of yield strength. So once you finalize the value of SUT minimum and SYT minimum, then you have to solve this condition and find out the value of tau allowable. In that case, we have the factor of safety FOS will be tau allowable divided by the maximum possible shear stress tau max. Using this, we can calculate the factor of safety. So this one is slightly typical procedure to find out the value of SUT minimum and SYT minimum. But this practice is preferred in the industry. So I introduce you how to find out the value of SSY or tau allowable in the welding case. Suppose you come across a fillet weld of the two material SAE1020 and SAE1015, for which the value of SUT is 383 megapascal and for 1015 SUT is 348. Corresponding value of SYT is 208.1 and 191.3 megapascal. And suppose you selected the electrode E7010. In that case, we have SUT is equal to 482 megapascal and SYT is equal to 393 megapascal. For electrode E70, we have SUT is equal to 482 and 393 megapascal. Now, how we are going to find out the value of SSY, that is tau allowable? For that one, you have to first calculate the minimum value of SUT out of electrode, then the parent material 1 and the parent material 2. So out of these three, we'll find here the minimum value is 348. So we have SUT minimum will be equal to 348. Similarly, SYT you have to find out from these three value of electrode, parent material 1 and parent material 2, and you will get the value of SYT minimum. Out of 393, 208 and 191.3, minimum is 191.3 megapascal. Once you finalize the value of SUT minimum and SYT minimum, then you have to use this equation. So allowable shear stress will be minimum value of 0.3 times of SUT and 0.4 times of SYT. So you have to select the minimum value of 0.3 times SUT, which is equal to 348, and second value you have to calculate as 0.4 of SYT, which is 191.3. So if 0.3 multiplied by 348 is same as 104.4 and 0.4 multiplied by 191.3 is 76.5. In that case, we have to take the value of tau allowable is equal to minimum of these two value, which one is 76.5 megapascal. So in this fashion, the calculations are done in the industry. As far as the GATE exam is considered, they will give you directly the value of tau allowable. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.